So 2.1 day 2, we are going to find the derivative of functions. The equation up there, does it look familiar?
Yeah, it's like the first one, except instead of C's, it's X.
It's X. It is exactly the first one.
Do I need to write down?
Well, that's up to you. That's up to you if you want to. I will tell you it's a derivative. Okay, your world for the next whatever, through this first semester, actually for the rest of the year, derivative is something you just are going to do. The definition of the derivative was you are finding the slope at any given point. Yes, last week.
Mm-hmm.
Okay, that is you're finding the slope of the tangent line. So the definition of a derivative is the instantaneous rate of change. It is the slope at any point on a graph, because we're not linear anymore. So that's what derivatives are. So we have this prime, it's f prime. Now, in geometry, that means change. In calculus, that means derivative. Okay? When we did inverse functions, we used a prime. No, we didn't do a prime. We did a -1. Yes? So that prime means derivative now to you. Now, I'm also going to give you another way you could write this equation if you would like. You could say the limit as h approaches 0. Now, h, when we do y equals ax minus h plus k, h is that vertical movement, correct? Isn't change, not vertical, horizontal. Isn't change of x horizontal movement? Yeah. You're bringing that h, those two points closer and closer and closer and closer together, so you get that one exact point you want. So we can write it as an h, which might be a little bit easier to write out, but is it any different? No. I don't care which one you use.
They both work the same?
It's the same. Rather than writing change of x and having to put parentheses around it and put squared, you can just write an h.
Okay. So h is change of x?
Yep. Okay, so the new function you have will be finding the derivative at any given point. So if I find the derivative of a function, my derivative is an equation to find the slope of that line at any given point. Now, I'll still have to plug in the point, but I can find the slope without going through that whole process again. Okay? We can write derivative many ways. We can write it prime. We can write dy over dx. We can write it y prime. We can write d dx of f of x. Well, what is f of x, guys? No, what is f of x? Isn't it just y? Yeah, so this right here is the same as that. Okay, you can also write it capital D sub x of y. All of them mean find the derivative of y with respect to x. What that means is x is going to be the variable. Y is the equation. We will have points where we find the derivative of y with respect to x, but you do it exactly the same. So there are many ways to write derivative. There are times we write dy over dx. We write d dx. It's usually these two are the ones that we will write most often, but they all mean derivative, that instantaneous rate of change. It's a slope function of a function. That's what it is. Am I good?
Yep.
Okay. So, this just is showing you, don't worry about writing anything down unless you really want to, but listen to what it says. It says the notation dy dx is read, and we say legitimately dy dx. It's what we say. When we read this, we say dy dx. Is read as the derivative of y with respect to x. I've said that, but I say dy dx, and in your head you hear the derivative of y with respect to x. X is the variable you are differentiating. okay? Or simply dy dx. Using the limit notation, we can write dy dx equals the limit of the change of x as opposed to 0, change of y over change of x, which gives me that limit formula that we've been using. And our result is our derivative. Okay? So find the derivative of f of x equals x cubed plus 2x. So guess what I didn't do? Okay, so we're going to find dy dx of x cubed plus 2x. And I'm writing this way so you know this says find the derivative of y with respect to x of x cubed plus 2x. So dy dx equals the limit as x approaches, not x, h. H approaches 0. And remember, we're going to have f of x plus h minus f of x over h. Is that correct?
Yes.
Okay. Call me out if it's not, because this is not the way I do derivative. I can tell you right now the derivative is 3x squared plus 2. 3x squared plus 2 is our answer. Okay? And,
How do you do that?
yeah, not till tomorrow. Got to do the long way first. Okay, so we have x plus h cubed plus 2x plus h.
Enter in the.
You put this in
Uh-huh.
for x here and here.
Okay.
Okay?
Oh, okay.
Minus x cubed plus 2x. And I put it like that so you can see the difference. All over h. Okay, so if you remember your Pascal's triangle, this 3 is 1, 3, 3, 1, right?
Yeah. You have to start on top of it.
Okay, so this means I'm going to take x plus h times x plus h plus times x plus h. So if I can remember 1, 3, 3, 1, it would be much easier, yes? Okay. So this gives me the limit as h approaches 0 of x cubed plus 3x squared h plus 3x h squared plus h cubed. Whew. You're 1, 3, 3, 1. 1, 3, 3, 1. X's go down, H's go up. Remember doing that now? You'll get better at it, but do you remember doing it at all? Okay, now distribute your 2. So 2x plus 2h. Distribute your negative. So negative x cubed minus 2x. All what you did last Friday, correct?
Yeah.
All over h. Isn't the h much nicer than the change of x?
Yes.
Okay, now I don't think the book introduces that to you later. I just didn't know. Okay, so what can I do?
Cancel out.
I can zero out the cubes.
Yep.
I can zero out the 2x's.
Yep.
And I can reduce 1h from everything, correct?
Mm-hmm.
Or do you want me to factor it out? We'll factor it out this time. And then the next time I'll just start crossing off. So I can factor out an h from the numerator.
Square.
No, I was seeing if I could fill any, like, combine any like terms. All over h. Now the h and the h reduce.
Wouldn't that? Never mind. I was about to ask.
Yep. Okay, now we're ready to do the limit. As h approaches 0. So that zeroes this out. Yes. It zeroes this out. So f prime of x, or the derivative of x, is 3x squared plus 2. And what did I tell you it was going to be? So, any different than you did last week? Absolutely not. Except,
Besides the letter change.
yes, and you can thank me now. You're welcome.
Thanks.
Okay, find the derivative of the square root of x. Then find the slope of the graphs at the point 1, 1, 4, 2, and 0, 0. So what that means to do oh, it won't give me my words back? Oh, okay. On the last slide, we had 3x squared plus 2, yes?
Yeah.
So f prime of x, I told you that gave me my instantaneous rate of change, or my slope at any given point. So all I would do is plug in my what? X's. Am I going to have 3 different slopes?
Yeah.
Yeah, because this is not constant. It looks like this, doesn't it?
So you just plug them into that.
After we find the derivative.
Okay.
Okay? Because the derivative is the instantaneous rate of change, the slope at any given moment. So we need to write this. We need to find dy dx of, well, that should be x to what exponent? What exponent is the square root?
1. Squared.
Isn't it 1/2? So the square root of x, there's a 2 out here, yes? And the power is 1, so it's x to the 1/2. What is the cube root of x squared? What exponent is that? X to the 2/3. Remember doing that last year? Fractional exponents?
Yeah.
Okay. We're going to do lots of them. Okay, 1 is the power, 2 is the root. So I need the derivative of x squared to the 1/2. So that's going to be the limit as h approaches 0. And again, it's f of x plus h minus f of x over h. And our answer is going to be 1/2 x to the negative 1/2, and then we're going to have to simplify it. Okay, so this in for this x. So I have x plus h to the 1/2 minus x to the 1/2 all over h.
Yep.
So how am I going to simplify that?
Good question.
What do you think? You want to try? A no is something. A no gets me somewhere.
I don't know, you have to use what we did with the Gaussian, like the exponent being like that. I think you have to like FOIL it.
Well, you can't FOIL a 1/2, right?
Someone with a reciprocal.
Oh, you mean the
Like, yeah, Can we get rid
Not
of
the
it?
reciprocal. What word are you thinking?
Exponent? Starts with an R. Does it?
No, are you thinking conjugate?
Sure, but that's right.
Or are you thinking conjugate?
No.
No, you're
I
not.
know what conjugate is.
Okay. You know what a conjugate is? Okay. So my problem in here is I have that quantity to the 1/2, yes?
Uh-huh.
And I can't distribute a 1/2, like, because I really have the square root of x plus h. I can't do anything with that, can I? So I do need to multiply by its conjugate. So I'd have x plus h to the 1/2 plus x to the 1/2. And I do that on the bottom and the top. So that gives me the limit as h approaches 0. And on the denominator, I'm just going to write it. I'm not going to do anything with it because if you guys, I mean, you haven't really done it that much, but every single time we are factoring out an h, right?
Yeah.
So why would I distribute it to factor it out? That just doesn't make sense, does it? Okay, so now on the numerator, I have to multiply these two times each other. And we know that when we have conjugates, if I have x minus 4 times x plus 4, the middle term is going to zero out every single time, right? And so you square the first and you add the square, you subtract, not add, because a negative times a positive is a negative. So that's what we get, right? Every single time we do a conjugate, correct? So we're squaring the first, subtracting the square of the second. So when I square this, when you square a square root, don't you get what's inside? So I would get x plus h, correct? Minus,
So you're just squaring it?
I'm just distributing. Like when I do this, the middle term zeroes out. That's the whole point of the conjugate.
Well, where did that come from?
Where'd what come from?
X squared minus 16.
I just showed you. I was just showing
that
you.
example.
That was just an example. Okay, so now I have x to the 1/2 times x to the 1/2, so that's just x,
Okay.
correct?
Yeah.
Okay, so the x's reduce out, and the h reduces out, so I'm left with the limit as h approaches 0 of 1 over x plus h to the 1/2 plus x to the 1/2. So now I plug in what for?
You plug in the points.
I plug in, I got to do the limit. So this becomes 0.
Yeah.
So I have x to the 1/2 plus x to the 1/2. So f prime, not x to the 1/2, x prime of f, so the derivative of f with respect to x is 1 over 2x to the 1/2. Now, can I leave x to the 1/2 in the denominator? That's the square root of x. Can I leave that in the denominator?
No.
Nope. So I have to multiply by x to the 1/2 and x to the 1/2. So it gives me f prime of x equals x to the 1/2 over 2. Or 1/2 x to the negative 1/2. What does negative 1/2 do to it? It puts it in the denominator, doesn't it? And is that what I told you the answer was going to be?
Yeah, so it could be the x 1/2 over 2 or x 1/2?
No, you need to finish it out and do this.
So it's not x -1.
Well, it's 1/2 x to the -1/2, but you can't have you have to fix it.
Oh, because all I can see on the board is x -1/2.
Oh, I didn't realize it cut it off. Sorry. I need to quit using that much of the board. Okay, so now I have my slope function. This is my slope function. So I just need to plug in my x's. So we have m at 1. So it'd be 1 to the 1/2 over 2, which would be just 1/2. Because that's the first point.
Yeah.
The second point is 4. So m at 4. So 4 to the 1/2 over 2. Well, the square root of 4 is 2. And 2 divided by 2 is 1. And m at 0. Oops.
Do we have to do 0, or it says discuss the behavior? So after when it says that, you have to like tell what it's doing, or is it just the same?
Oh, well,
thing as-
let's do it. Do m at 0. So it'd be 0 to the 1/2 over 2. So it's 0 over 2, which is 0. So we need to discuss that. This is what's going on, right?
Yeah.
So, well, this is a square root. So we know it looks like this, yes? So it starts at 0, doesn't it?
Yeah.
So what's the slope right there?
0.
0, because that's where it's starting, right? But technically, if I do tangent line, my tangent line's going to run like this. So it's a vertical tangent line. So what do I get? A slope of what?
Mystery.
What's the slope of a vertical line?
Infinity. Undefined. 0.
The vertical line doesn't have some. 1.
You know what? I reduced it's 0. But we reduced this wrong. Or I did, and you guys didn't catch me. We moved the x to the 1/2 up top, but what didn't we do? What's x to the 1/2 times x to the 1/2? X. Yes? So this should be over 1, which would still give you 1/2, yes? But this should be over 4. So this was 2, so it would be 1/4. And this one wouldn't be 0, it would be what?
It'd be undefined.
It'd be undefined. Because we're dividing by 0. So you get undefined. I was like, why did we get 0 for a slope? Because we should have got undefined. And it's undefined because that tangent line right there is vertical, isn't it? And the slope of a tangent line is, a slope of a vertical line is undefined. There's a lot of colors on there. And I need to fix my screen. I didn't realize you weren't seeing all of it. Now I understand why you asked me that question of where did that x plus 4 come from? Because there's an x minus 4 over here. Sorry.
That's fine.
So again, any different than what you were doing Friday? Nope. You're just going to do what after you're done?
Plug in the x.
Right. So if I ask you to find the slope of the tangent line, I'm asking you to find the derivative and then plug in the x. Because this right here is the slope function of the function. So I could ask you at any point forever what the slope is. Now as this gets bigger and bigger and bigger, it's almost flattening out, right? But is it ever going to be a 0 slope?
No.
No, but is it going to be pretty close?
Yeah.
Yeah, as those numbers get bigger and bigger and bigger. Because look at just at 4, it went to 1/4. So like if I did 20, or let's say an easy one, let's go 36. Well, that'd be the square root of 36 over 2 times 36. So this would be 6, and this would be 3, and this would be 12. So it'd be 1/12, right? It's getting pretty small. So, all I've got are more examples, like, we can, the reason why I have more examples is because they look different, okay? So the book would write it like this, and that's horrible, right? We're going to find the dy dx of 2 over t. Okay? So we do the limit as h approaches 0, and we're going to do the f of x plus h minus f of x over h. You guys know that by heart now already? Good. Okay, so then we're going to have 2 over x plus h minus 2 over t all over h. So then I have to get common denominators up here, which is going to be t times x plus h.
Well, now I'm confused.
What?
Well, did you put 2 over x?
Oh, that shouldn't be x plus h. That shouldn't be t. That should be... Oh, okay. I get it. Blah, 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 blah. Okay. Let me go back here. This was an x because we were doing x. It's going to be a what now? Not an x, a t.
Okay.
Sorry. So t and t. You should have been confused because there cannot be an x and a t. Okay? And then we're going to multiply it by 1 over h. Where'd the 1 over h come from?
You flipped the
Yeah.
denominator.
I'm multiplying by the reciprocal of the denominator, right? Okay, so I got to multiply this by t. So I have 2t minus, and I have to distribute t plus h with the negative 2, right? So minus 2t minus 2h. All good?
Yep.
Okay, so I have the limit. As h approaches 0, these two are going to zero out. So I have negative 2. Can I reduce these h's?
Yeah.
Okay, negative 2 over t plus h. So my h is going to become what? 0. So f prime of x, or the derivative of x, is negative 2 over 2t. So it is negative 1 over... How about t? Not 2. Okay. So then, if I wanted to find the slope at any point, could I plug in my t's?
Yep.
Yep. So this t is something to do with time, right?
Yeah.
Would we need to know something at any second? Yeah, we would, especially if it wasn't constant. So you're doing the same thing as you were before. They're just saying, instead of saying finding the slope of the tangent line, they're saying find the derivative with respect to x.
I think this is easier than Thursday because the chain of x or something about it will like throw me off, but it's just x or h.
H. Now just putting the h kind of makes it a simple, because it's hard to see this as one thing. And that's why when we square it, I always do that. And it's really hard for me to teach it with the change of x because I want to do h. And I think the book, I'm not sure when it tells you h, but there's no point not to put it in there. And again, so here's your graph, yes? And as I bring these 2 points closer and closer together, I'm changing the x, so it's change of x, but we also know that h talks about the movement in the horizontal axis as well.
Yeah, I think they should just put the H instead of making it look like gibberish.
Well, the whole point is we need to know when you see delta, that means change every single time now. If you're in physics, are you guys in physics?
I am.
Okay, you should be using deltas in physics because you're talking about the change of things.
I feel like
So-
we will. Right now we're working on just like
Sine,
basic
cosine,
flip-
tangent.
No, like flipping like the letters and separating.